Hey y'all, Data Guy here. So a question I've been getting from some of y'all recently is to kind of do more end-to-end style projects. And since this is the big Snowpark week over at Snowflake, I thought no better place to start than creating a sentiment analysis engine with Snowpark ML, showing you how you can get kind of the most use out of the new Snowpark Python feature, some of the user-defined functions there, to create a real ML model training mechanism. So this is going to be full, you can see the full architecture. I'm going to drop this link in the description where if you zoom in on this, you can see that we're basically going to take in a data set. We are then going to use Snowpark to transform it, write some user-defined functions that will feature engineer that data. Then we're going to perform natural language processing on it to determine the sentiment of that data. In this case, the data is these different movie reviews. So our end result is going to be just feeding in a raw movie review, and then the output will be either a positive or negative sentiment indicator. And so we're going to be referencing this GitHub repo, which again, link will be in the description. So you can kind of follow along with me as we build our environment from start to finish, build the loading mechanisms, build the data prep and training models, build the catalog. Every step of it we're going to cover here in a more end-to-end style. So I hope this kind of matches what some of you were looking for. And without further ado, let's get into it. So I'm going to switch over to VS Code and we're going to start off there. So the first thing we're going to do is clone this repo to our local machine so that we don't have to bother just kind of copying and pasting all the files. We can just build off the backs of what they've already done. So this is actually going to contain a lot more than just the particular Python scripts we need. So let it all download, but then you're only going to be going into the NLP ML sentiment analysis folder. And if you don't want to just have all these extra Python projects on your local machine, just download that folder again from the link in the description. So I'm gonna let this finish up and then I'll meet you back in a second. And that literally took a second. So now we're in here, we're going to CD into Snowpark Python demos, and then we are going to CD into Snowpark NLP ML demo. Clear, and then if I list this out, you can see we'll have various different files here that consist of this project. So I'm going to then open it up in VS Code. So we just have a folder that we're working off of that isn't just a blank screen. So here, Snowpark ML demo. This has all the data, all the SQL, all the code you'll actually need to run any of these workflows. But before we actually run any of the code, we're going to need to create a specialized environment for it. So here, what we'll do is go to our terminal command line interface again, and then what we'll do is conda update conda. Make sure conda is updated in the most recent version. That's cool, around Python 3.11. Let me just move this over a little bit for you. See. So after we've made sure conda is updated, we're also going to update the Python in there, and then we are going to create a new Python environment. So meet you back again in just 1 second. So once you made sure all those things are updated, then what we can do is actually create our virtual environment. So here, conda environment create, and then this is creating an environment based off of this YAML file. So within here, Snowpark environment, that defines all the different packages and dependencies that we want this environment to have. And the reason why you want to do this rather than just using your base Python environment is because this project requires a lot of different specific Python package versions. So best way to make sure you have all those and not have to screw up your own computer's environment is just base a new conda environment based off of kind of this YAML file of different packages. So that's kind of why we're doing that here rather than installing it all individually on our base system. And so while this downloads, we'll actually go over to our connection.json file. So what you're going to do is just fill out all these different fields with your various account details. And this is how we're actually going to authenticate into your Snowflake environment. So for obvious reasons, won't show out all my details here, but you can see the different fields that you will need to fill out here. So now that we have our environment all stood up, everything's installed, it's time to actually activate it. So to activate it, you're just going to run the command that tells you actually within the conda UI, but just conda activate NLP ML sentiment analysis here. And then so this will give us access to this specific environment. And then so what we'll do is go cd Streamlit, and then Streamlit run sentiment underscore analysis app.py. And so while this spins up the Streamlit environment and actually starts running it, I'm going to go over to the Python code so we actually know what's happening within the Streamlit app. So This is quite a doozy of a Streamlit app. And so I'm going to just go through it step by step at a high level here. And then for each of the individual steps, as we kind of get to that process of setting up that data pipeline, I'll go back in more detail. But I think it's important for you to kind of have an idea of the general project structure. And so this project starts out with, obviously importing kind of all our different Streamlit and Snowpark, different packages, pandas, NumPy for interacting with data, and then just prints out the Streamlit or Snowpark version. Then we have a function that will create a connection into Snowflake, which is using our connection JSON file that we used earlier, adding a certain amount of packages that we are around Snowpark Python so we can actually interact with our data within Snowpark and leverage that Pythonic compute engine. Then another one here that's just creating a temporary connection that you'll eventually use to just collect different data, the current information around that different connection. So just basically an informational one, but one that, in case we need a second connection that, is just more temporary and isn't as long lived, that's our option there. And then in terms of the ML functionality here, we have our train model review pipeline. So this is this part where we're actually taking in the data and then using it for our sentiment analysis. And so the way this works is it's using NLTK, what you can see here for stop words, and Scikit learn for SVM and text feature extract. Stop words are just words that might actually add any meaning to a sentence, like such as, is that, which, and on, just really words that can be ignored without sacrificing the actual underlying meaning of that sentence, since we just want to look at the sentiment. We don't care about really the sentence structure. And then SVM just stands for support vector machines. And that's just a way of vectorizing and kind of transcribing the raw text data into more easily consumable vector data. And if you're interested in what that term means, check out my Common ML Terms Explained video, because I kind of go through each of those. And then so here we're doing just pretty typical stuff. We are setting a testing and training data set. We're setting some, review these certain values. Then what we're doing is just having a few different parameterization methods. So setting our tokenization, setting our max size for the data frame, basically all the different parameters of how we want to actually look at and transcribe this data. And so this is just different ways for us to look, hey, I want to see just the different max token amounts. And this is just a count vectorizer. You can see there, which is a critical step in NLP and machine learning for text data. The analyzer here, uWord, this determines the net level of analysis for tokenization. So when it's set to word, it means the vectorizer will tokenize at the word level. So it'll take each individual word and take a vector of it. Then the n-gram range. This is choosing, hey, I want to capture, or 1 and 2 means I want to capture not only single words, but also double word pairs. So it can help us in the contextualization of having, like 2 pairs together, like ugly person or stupid data, things like that, that give you kind of the more in-depth understanding of what's actually happening there. And then we also have, so DF, this max DF sets the max frequency threshold. So words that appear in more than 2% of your documents will be ignored, because that helps you remove any kind of common words that might be too frequent and not really informative enough for true analysis. And that's also similar to stop words. And then the minimum frequency threshold is just say, hey, look at the word, words that appear in less than this fraction of the documents will be ignored. So this is dynamically being set based off of the training data. So what this will do is just exclude really, really, really rare words that are only, appearing like once or twice across all of our documents, because they probably won't contribute much to the overall analysis, since we're looking at this kind of from a high level view. And then take all this information, build it into this count vectorizer, and this vectorizer will transform our text data based off of those configuration details that we just gave it. Then we're going to normalize the data, then fit an actual model to it, and then create a stage to store the model that we just created based off of that vectorized data. And this is just a linear model here, so nothing, just a linear SVM classifier, which is, again, just a vectorized classifier, so nothing super complex here. Saving it in a staging table, as well as saving that vectorizer method that we did into a stage as well, so that way we can call both of these within the confines of Snowpark and use them there. And then finally, upload that trained model to a stage as well. So we have a trained model that will return its success. It's our score of training for us. So we have an idea of how actually accurate that model is. Now, after that, we've also created a function to load the model from the internal staging table, where we're just loading in from that Snowpark Snowflake import directory, any files, in this case, just the model, from our internal staging, which we just uploaded to in that previous function. And then down here, it's really just a lot of different functions here to help our actual Streamlit app to interact with and leverage different parts of that model. So here under define train model, we have the different characteristics of that warehouse where we want to actually run the model in. We're registering it to the Snowpark internal model registry, calling that. So we have a function to actually call that from our Snowpark app, and then also deploying a user-defined function, which will say, hey, load the data, load our file of that vector review, and then use the features, which were review and sentiment flag here, transform a data frame, and then return the model prediction based off of the uploaded review. Then down here, we have another function, which is just going to give us the scores of how well that model resulted performed. And then we're also going to look at the performance of our performance and just put it into a data frame. So this is similar to the last one, but instead of just returning raw values, we're going to convert this into a data frame where you can see you have different scores contained within there. And data equals t, returning that as a pandas data frame, so just more easily displayable. And so the rest of this code is really just different kind of Python code to actually define how the application looks. And so that's where we get to the fun part, which is how does a Streamlit application look? And it really is a thing of beauty here. So kudos to the developer of this. But you can see here I have a nice interface where you can see all the stuff from GitHub. But then I also have the different steps of setting up, loading data. You can see these as I load through the pages here. You have different buttons to kind of perform a lot of the operations that I'm now going to show you how to build. But if you just want to get in here and start, loading training data, you can just do that via these buttons. But since this is an end-to-end project, I want to show you, how to create everything individually. So now we're going to kick it over into Snowsight. I'm going to show you how to set up the tables that we're going to need to actually contain all of this data. So let's move over there. So now within Snowsight, what we're going to want to do is just create a new worksheet. So go up, hit the good old blue plus button, call it a SQL worksheet, and then what we're going to do is account admin, and just choose whatever database you want to run these in. So I'm just going to use compute warehouse, and then what we're going to do is create database if not exists, IMDb. So here, use role account admin and run all. And this will just create our IMDb database here. And then what we're going to do is create a couple different tables using this database. So here, have create or use database IMDb, use schema public, create table if not exists, and then just scroll that down there. And then, again, creating tables for training and testing data sets, run these, boom. So now we've got our tables all set to contain our data. And then finally, we are going to create our warehouse if it doesn't exist. So here, demo warehouse, demo WH, and this is where we're going to run the rest of our code. And then finally, create stage, if not exists, models, make sure we're in the demo warehouse, IMDb public, and then we're going to create stage, if not exists, models. Boom, awesome. So now we've got all of our tables set up. So what we'll now have to do is load our Python data into Snowflake. And here's where I'm actually going to switch over to using the kind of notebook style version of this, because this will just help me go step by step to everything that's happening in the Streamlit app, but actually showing you the underlying code. So all this functionality, and you can see this in the description, is exposed via the Streamlit app, and you can do it there, like you saw me click load data set. But the interesting part is knowing how the code is actually built. So that's what we're going to focus on here. So first thing we're going to do, just import this kind of image here just to make sure that, hey, your table should look like this. And if we go into Snowflake and go into our databases here, you'll see we have this ImageRect database, which has an image schema and an information schema and nothing in public yet. So we still have some stuff to do, but we have this IMDb database where we have within our public, our table, our testing and training data set. And so we don't have any review predictions yet, so we don't have that table there. But let's go back into our VS Code notebook. You can see here, we're going to just import these libraries, import and create a Snowpark session with all those things that we uploaded with NetScript earlier. So here, Snowpark version is 0.11, and then we're going to just create a connection into our Snowflake and Snowpark environment using that existing JSON that I had you fill out at the beginning of the video. Then we're going to import any needed packages into the Snowpark session. So these are just, again, importing in all the different ML packages we'll need. And then make sure that we are actually in the correct database. And it looks like this is suspended, so need to fix this. It's actually saying it's not going to suspend it, but that's fine because I don't need to suspend it. So we'll just kind of move on here and ignore it. If it causes trouble later, we'll fix it then. But here, what we're going to do is just upload that training data set. So you can see here, if we just press play, this will upload, or just our training data into that training data set. And all this training data as well comes from this Kaggle link. So if you need the data, just go there. Again, this is all will be in the links, but just want to show you, each step of the way here. Then what we're going to do is train a data set where sentiment isn't null, and then show it off here. And so we haven't reviewed any movies yet, so obviously aren't able to do that. So what kind of just tripped me up there is that when you actually use this GitHub file, and I didn't notice this before, I was wondering why my data wasn't getting uploaded, is make sure you unzip these test and training data sets into their CSVs. Otherwise, it'll give you a success message when you run this loading data function, but it won't actually load any data. So really crucial that you do that. And so what you should do is just kind of after you run through the initial setup processes within this notebook, you don't really need to use this notebook. I'm just doing it to kind of show you the code. But everything you're seeing within here, like this function, this is just the function that I showed you within the Streamlit app earlier. So now I'm just going to switch back over to the Streamlit app just so you can kind of see. So just like the idea of, hey, these are all just pieces of that Streamlit app in a notebook. So if you want to look at them individually. But within the Streamlit app, you're going to want to hit load training data and then load testing data set. And then hopefully, if this worked correctly this time, yes, it did. This will show you rows of your data of your movie reviews that we can then use for our sentiment analysis. So this is where you're going to need to go to actually just upload the data. And this is analogous to if I just did kind of a for loop where I just loaded the pandas CSV as a data set. So all these buttons are really doing under the hood, if we just add a code block here, is just executing this statement. So it's just opening a local CSV and then writing that as a pandas data frame into our Snowflake environment. So just hit those buttons just to make it easy, but this is the underlying code that it's actually using. So just, good for you to know as you try to use some of these concepts in your own life. And so then after you have all your data loaded and you are made sure that everything is all set up there, we can then go into our analyze step here. So if we go into analyze, and just load up this here. So you can see our two tables that we just uploaded that are available. This is plugged into our backend database, which is just Snowflake in this case. So within this analyze page, so if we go look in the code before I actually kind of run you through it, here we're just creating a Snowflake connection, creating or selecting our information schema table to just getting all the information around the tables that are available for analysis, then pulling them out as Snowflake tables, as pandas tables, and then displaying those resulting tables within Streamlit. So this is going to take all relevant columns, convert that to a pandas data frame, and then display the pandas data frame within our Streamlit app. And so that's what's happening there when it's getting information around those tables and saying these are the available tables there. Then you have the ability to select a table so table to print. This is going to list the different tables. We have the subheader to analyze, select the table to describe the statistics. And so once the table is described, what this code will then do is fetch all that data that's contained within that data from Snowflake. So it's going to first session table, access that stored table, retrieve the first 10 rows of that table for a preview, and then loading them into a pandas data frame, and then generating all the descriptive statistics around that column as well. And then we're going to just use some Streamlit functionality here to organize the data, display the total row count, and also, positive or negative, whether or not the sentiment for that review is positive or negative. And so going back into, what this is actually doing. So here, what we can do is select a data set. So testing or training, let's just select testing for now. And here we can see some statistics around that data set. So you can see the total amount of rows, which are positive, which are negative, almost even split. And then down here, we have our sample data. So this is the public.test dataset. And here it's just showing, again, those first 10 rows of the data. And you can see, kind of some of the reviews here as well as the sentiment. And then finally, down here, we have data description, which is just using that information schema table to give us some information around it. I mean, this is text data, so it's not really super great at min and max, but here it is if you're looking for that kind of a printout as well. Now, the next stop on the Streamlit Express is we're actually going to train the model, where we're going to select a table to train the model on, select a warehouse that's actually going to provide the compute for that model, and you can see kind of the current configuration here of our warehouse and the algorithm used. And so what this looks like behind the scenes is it's basically that train model review pipeline that we created earlier. So this is a big heavyweight function that I kind of went through previously, where, close this out, you can see all the different steps of our ML pipeline here in this train model review function. And then this is all just being called within, if we go down to the left, not load data, not analyze, but train model function, where we're just going into creating that Snowflake connection, choosing what data set to train, which is again using a similar method to pull the information around the data set and surface it via the Streamlit UI. Then we also have just selecting all our different tables here, selecting our config. This is just a lot of stream interfacing for determining the different menus that you just saw there, and writing out, hey, this is the algorithm we're using, the virtual warehouse, the size of the machines, and then just prompt to use an optimized warehouse for large trainings. So really the meat and potatoes of it is that is this model review pipeline that I discussed earlier, where we're vectorize that information based on these parameters. So if we go back here and actually train our model, we can let's do our training data set. We're going to just use the medium warehouse. I don't think we'll need a larger one. And then just hit train model here. And then I'm going to let this run for a second and be back with you when it's done. So while there's not really much of an output on the screen other than it finishing running, now we have a trained model that we can call from using that user-defined function that we called earlier. And so again, if you just forgot what that looks like, so here we have, this is the UDF, which is deploying that model onto Snowflake, so we can then use it for predictions. So you can see here, it's going to load that model, load our vectorized data from that testing set, and then use it to generate a prediction of these two features or sentiment. So again, just going through those same steps that I kind of laid out earlier, where you have, call it after you've trained the model, you then have to save the model within Snowpark so you can then call it as a user-defined function, which is Snowflake's way of kind of allowing you to create functions within Snowpark using Python. So now that we're done with that, we can do next is move on to the model monitoring and model catalog, which is important before we actually do our predictions. So here within, just want to show you the two functions behind the next screen I'm going to show you. So first we have our model monitoring function. And so this is just creating a Snowflake connection and then getting all the information about our query history within this given table and surfacing it within table within our Streamlit application. So this is just useful if you want to keep a tight eye on all the historical run information, so that in case you want to replicate a certain scenario, you have that information available. And then additionally, we have the model catalog, where all we're doing is just creating a Snowflake connection and then just using that Snowflake connection to list all the available models within our Snowpark environment. So nothing too complicated there, but just worth it to see the actual code that we're running. And so you can see here under monitoring, we can refresh this, and this will just show you all the SQL queries that I have been running. So you can see just all the different functions that are actually happening underneath the hood. And then in our model catalog here, if we refresh, you can see the two models that we have created. So our model review and then the vector of that model review that has all that vectorized review information to compare to. And so now we're finally all set up to go into this inference stage. And so this is where we're actually going to run this model and get some to analyze the test data set and then see the accuracy of our model after the inference. And so before we see what that actually looks like, what I want to do is just, again, quick go through the code here. So we see here for option inference, again, create a Snowflake connection, have our subtabs of test data set and the accuracy of it. And so here we're going through, creating our test data, or pulling in our test data set, creating a data frame where all of our sentiment analysis, if it's positive, we're going to say it's 1, otherwise it's going to equal to 2. And then what we're going to do is df predict, so select the predict review and just create a new data set with the review and the sentiment flag with the alias of predicted review. So this is going to allow us to save, hey, what is a predicted review versus the sentiment flag? And that's why we stored the sentiment as a separate value. And then writing that model, saving as a table as review prediction. So this is where we're actually going to be generating our review prediction table. And then you can see here, similarly to other tasks, we're also just going to create a few functions, I guess, within Streamlit that are just going to give us some high-level information around how many positive values were found, how many negative values were found, as well as just the total number of reviews that we used. So here, this is really the meat and potatoes of it all, where we're writing that model, saving or using that model to predict the actual review or predictor review of each given movie based off of the sentiment score. So the predictor review is really just, is it a positive or is it a negative? So just something to note there, even though it's worded a little bit differently. So here, this will give us, this table gives us the test data set. We'll go through all of our different data here, assigning a sentiment flag, so again, base if it's 2, sorry, I mixed it up. So 2 if it's negative, or no, I didn't mix it up. I got it right. Negative equals 2, positive equals 1. And you can see here just all the different reviews, and as well as the high level understanding of, hey, how many are positive, how many are negative. And then you can see our precision is 100 because these are the actual values. So obviously they should be 100% correct. Otherwise, I don't even know. There just isn't another option for them not to be correct. And so now that we've got that all done, we have our inference runs. And so this is where we can actually run our predictions on our data set. So before we do that, just again, want to look at the code here. So below inference, you can see here, creating our inference runs. So here under the hood for our inference run section, first, again, creating a Snowflake connection. And then what we're doing is fetching the list of tables, getting that table name, which is just going to be our testing data set. So pass that in dynamically, selecting the data set we want to predict. And then for the data set that we actually want to predict, it's going to create a pandas data frame of just the different attributes of that particular data set. And then we're going to select that table. And then once that data has been selected, we'll be running our previously saved model. So that's where this call UDF. So predict review, this is how we're actually running the model on this particular data set. Because previously, again, we created that machine learning model, saved it within Snowflake, and then define that as a UDF. And so that allows us to just call it by saying, hey, call UDF with the name predict review. So that's why there isn't like a traditional, dot model here. It's because we've already saved that within Snowflake because we're using the Snowpark compute engine to actually run it. So here, if we select our data set to predict, test data set, and then you'll see it's going to run. I already run it, but I'll just pause it again while it runs again. And boom, there we have it, our predicted review labels. So here, it took in all these raw reviews, created the actual review prediction using that user-defined function and then surfacing it here. And so you can scroll down here, look through all the different predicted reviews. You could also just go in here and see if I refresh this page, we should see a new predicted review data set under this public schema. And amazing, we do. So here we go, new review prediction. And so here's where we have our predictions and our results, sentiment flag, where you can compare the predictions to what the actual review was. So here, looks like we're doing pretty well. Let's see if we can find any consistencies. No, looks like it did pretty well. Luckily, sentiment analysis is a pretty easy thing to get well. So yeah, I really hope that this was helpful for people out there. I just thought it was a cool project that, shows a real world use case, shows you how to integrate everything into a Streamlit app and have just really a one-stop shop for running all of your sentiment analysis workflows and turn this into a true data powered app. So, this is something that a non-technical user, if you just added a position point to upload a file instead of just, having that manual insert or just running it, if you change the data from test data set and put your own data set in here, you could change this to actually analyze your own data. Just, make sure it's in the same format, I guess. But that is all I have for you today. There is this also this cleanup function, which is just going to drop everything if you want. I'm not going to run that. But if you want to just clean up your Snowflake environment after you're finished running, do that here. So I hope you like this kind of end-to-end connection or sentiment analysis engine video. I had a lot of fun going through it. It was definitely a little bit harder than my usual videos, but it's worth it. With great pain comes great pleasure. So I hope you have a good one. Data Guy out.